Today we're going to focus on what these graphs look like and some of the key things in the equations that will help you pick out the correct graph when you see the equation. The biggest hint is going to be whatever is added or subtracted at the end. This -4 indicates that this graph has been moved down 4. An original growth or decay graph has an asymptote at 0, at y equals 0. But if this graph moves down 4, we can go down 4, and that's where the new asymptote is going to be. It's also something to note that this graph also moves left 1, but with the way that these graphs are curved, that left 1 is harder to notice when you're looking at the graphs. The other thing that I want you to notice is whether or not there's a negative in front, because a negative in front will flip the graph and make it appear below the asymptote instead of above the asymptote. So this one should be above the asymptote. And I also want to notice whether it's growth or decay. So because it's 2 to the x, I know that it's growth. Growth means it's going to start, so if here's our asymptote, it's going to start close to the asymptote and then move away from it. Growth starts at the asymptote and then moves up and away. Decay starts far away and then curves down and comes closer to the asymptote. So if you are going to pick this graph out of a group of graphs, you probably have enough information right now to pick out the correct graph. But if we want to truly graph this, using the graphing calculator emulator that's on your computer, it may be helpful to get used to this graphing calculator, because if you ever do purchase your own graphing calculator, or if you already have your own graphing calculator, it is a good way to get to know how to use some of these features. To graph, we use the top left button that says y equals, and we're going to try to enter this equation as exactly as we see on our paper. So 3 times 2 raised to the x is the number right next to the alpha button, x plus 1 in the exponent, get out of the exponent and type in -4. Yeah, raise it with the exponent is like the exponent, the little caret button. Okay, once it looks like you want it to look, you can look at this graph by pushing the graph button on the top right of the graphing calculator. So if you're simply trying to match which graph matches this equation, you now have a picture of the graph. If your graph ever looks funky, a good keystroke to memorize is zoom 6. Zoom button number 6 resets it to a standard -10 to 10 on the x-axis, -10 to 10 on the y-axis. Now, if we actually want to graph this, we need points. So I push second graph. Right above graph, it says table. So second graph gets you into the table. And then you can pick out some of these points that you want to graph. So I'm going to pick out -1, -1, 0, 2, 1, 8. I think that one's off the graph. I probably should have grabbed the point -2, -2.5. And these don't have to be in order, but let's plot some of these points. -2, -2.5, -1, -1, 0, 2, and 1, 1, 2, 3, 4, 5, 6, 7, 8. So this graph curves up very sharply. And on the left side, it's going to get closer and closer to that asymptote, but not cross it. And you also want to make sure when you're sketching that you don't make it look like a J. That end should not come back up away from the asymptote. It should be going closer and closer to the asymptote. Okay. The hardest question of the day. I'm being incredibly sarcastic right now. What is the domain of this function? All real numbers. All exponential growth and decay graphs have a domain of all real numbers. The asymptote we already decided was -4. y equals -4. So the range is going to be y something -4. Because the graph is above the asymptote, it's going to be y is greater than whatever that asymptote number is. For the next one, we're going to go to Desmos.com and we're going to graph this using Desmos. So www.desmos.com. Yeah, you are. Yep. On your test, it does track your focus, but if you go to another tab, it tells me like what tab you go to. So I'll know that you went to Desmos, and that's totally fine. So that this is an acceptable aversion from your test. When you go to Desmos.com, at the very top in this little like, looks like a wave pool thing, there's a blue button that says Graphing Calculator. You click that. On the left side is where you enter your equations. On the right side is the graph. All right, so in here, I'm going to type in y equals, it's best if you start with y equals or f of x equals, -2, parentheses, 1 divided by 2, that's 1/2. Oops. You don't need to close the parentheses, it actually already gives the parentheses to you. And then I'm going to raise it, that would be Shift 6, the little caret thing above your 6. Raise it to the x, get out of the exponent, and then type in +1. And as you type, it puts that graph on the screen for you. And the cool thing about your touch screens is that you can move this around however you want to better see it. So you can definitely see on this graph that it has an asymptote at +1. It says +1 at the end, the asymptote is a +1, y equals +1. Also, the negative has flipped that graph, so it's below the asymptote. So if I go back to our notes, some things that I want to notice. This +1 means that our asymptote is y equals 1. The 1/2 tells me that this is decay. That means it's going to start far away from the asymptote and then move toward the asymptote. But the negative tells us that it's flipped. So if our asymptote is here at 1, it's going to start way down below, and then it's going to curve up and get closer to that asymptote. So just from looking at that equation, I know that the asymptote is 1. I know that my domain is all real numbers because my domain is always all real numbers. And that -2 tells me that there's a flip. So the range is going to flip and be y is less than 1. The graph is going to be below the asymptote. So the range is y is less than whatever that asymptote value is. Now, if you actually want to put this on the graph using Desmos, I don't expect you to like try to figure out the points on here. There's a way to have Desmos tell you what some of these points are. So in Desmos, right above these equations, there's a little, what do you call this? Like a settings wheel, a cog. So you click the little settings wheel and it gives you some options here. And one of them looks like a little table and it says convert to table. So you click convert to table and it gives you some of the points that are on this graph. It usually gives you points that are close to 0, but you can also type extra numbers in here. Like I could type in 3 and see what the y value is. I could type in -3 and see what the y value is. So you can type in any x value that you want and see the corresponding y value. I want to keep the points -2, -7, -1, -3, 0, -1, and 1, 0. So I just jotted those down on a little piece of paper off to the side so I can go back here. The points that I grabbed from Desmos are -2, -7, -1, -3, 0, -1, and 1, 0. So -2, 1, 2, 3, 4, 5, 6, 7. -1, -3, 0, -1, 1, 0. So this graph is going to start down below, far away from that asymptote, and then as you move to the right, it curves up and moves closer to that asymptote. Okay, my class tells me that these last two look kind of sus, so we're going to talk about these last two. Using Desmos or your calculator, you can enter these. Remember, E is the natural base. E is always a growth function unless there's a negative in the exponent. So this one over here is going to be a decay function, but this one on the left is going to be a growth function. So it's going to look something like this. Do you notice there's nothing added or subtracted after it? That means the asymptote is y equals 0. In the one on the right, see the -3? The asymptote is y equals -3. So don't let that E confuse you. You're still looking for what is added or subtracted at the end to tell you what the asymptote is. The domain is still going to be all real numbers. The range is going to be something with that asymptote. And if you aren't sure, type it into the computer, type it into the calculator, and see, is it above the asymptote or is it below the asymptote? And then you can pick that out. So if I graph this first one in Desmos, I would get rid of this equation I had. Y equals 2, and you can just use the E on your keyboard, not WE. Sometimes with E, you need to put parentheses around your exponent just so that it keeps it all up in the exponent. I don't really know why. That's something funky with Desmos. So here's my graph, y equals 2e to the 0.75x. And you see the asymptote at 0 just like we thought. You can then change it to a table to get some points if you wanted to graph this. Warning, the E functions are going to have crazy decimals. So if you're really trying to graph an E function, it's going to be crazy, messy decimals. But what I really notice about this graph is that it's above the asymptote. So if I go back to my notes, it's going to be y is greater than 0 because that graph was above the asymptote. Above the asymptote, it's going to be y is greater. Below the asymptote, it's going to be y is less than. On your worksheet, numbers 1 through 3 are matching with growth graphs. 4 through 6 are matching with decay graphs. Numbers 7 and 8, I want you to graph fully. So numbers 1 through 8, I want you to fully complete. On the next page, numbers 9 through 12, all I want you to do is find the asymptote, the domain, and the range. You do not need to graph. You can graph if you want to, but you don't need to on numbers 9 through 12.